Hi there! Welcome to the video on antiderivative applications. This application is going to focus on having a velocity function and then answering questions about change in position and total distance traveled. So let's get started. Here we have the velocity of an object in motion after t seconds is given by the function v of t is equal to 48 minus 24 times the cubed root of t in feet per second. And the first part says, what is the object's change in position after the first 64 seconds of travel? Well, that is just found by the definite integral from 0 the start to 64 for our after the first 64 seconds of our velocity function 48 minus 24, and we're going to write the cubed root of t as t to the 1/3 power to get it ready to integrate. And then our differential is dt. Now here I can just integrate term by term. So this is 48t minus 24 times, and for t to the 1/3 power we'll use the general power rule. So we will add 1 to the exponent. 1/3 plus 1 is 4/3, and then we'll divide by that 4/3 and evaluate that from 0 to 64. Simplifying this a little bit before we plug in, we have 48t minus, dividing by 4/3 is multiplying by 3/4. And when we multiply 24 by 3/4, we get 18. And that's t to the 4/3 power, and evaluated from 0 to 64. So we are going to plug in the 64 for the t's first. Remember, plug in that upper limit of integration to start. And then minus 18 times that 64 to the 4/3 power, and then minus plugging in the lower limit of integration, our 0. So 48 times 0 minus 18 times 0 to the 4/3. And as we go through and evaluate that, you will find that you get negative 1,536. So that is telling us that our object is 1,536 feet behind its original starting point when it ends, or after its 64 seconds of travel. So we will write that it's 1,536 feet behind the starting point. And that's after its first 64 seconds. Now part B asks, what is the total distance traveled after the first 64 seconds? So here what we need to do is make sure that we keep track of the distance traveled no matter which direction it's going. I have graphed the velocity function down here underneath part B, and you'll notice that the graph has some portion of it that's shaded above the t-axis and a larger region that's shaded below the t-axis. And that's actually in line with what we got for part A. We ended up with a negative value overall, and that's because more of the shading was below. For us to get the total distance, well, remember, the distance will be the same as the area when our area is above the t-axis, and then when our region is below the t-axis, it'll be the negative of it. So we'll have to take the opposite of that negative to add those together. So the first thing we need to do is to find this point where the graph crosses the t-axis. And that we find by just taking our original function 48 minus 24 times the cubed root of t and setting that equal to 0, because we want to find the t value where our function value comes out 0. Adding the 24 times the cubed root of t to both sides, we get 48 equals 24 times the cubed root of t. Divide both sides by 24, we get 2 is equal to the cubed root of t. And cubing both sides, we get t equals 8. So what we want to do for our distance is for our interval 0 to 8, we notice that's where it's above the t-axis. So we'll just calculate that. And that's the integral 0 to 8 of 48 minus 24 times t to the 1/3 power dt. We already found the antiderivative for this in the previous line, in the previous work. So we have that's equal to 48t minus 18t to the 4/3, and we're evaluating that from 0 to 8. When you plug in the 8, then minus plug in the 0, you get a value of 96. Now on the interval from 8 to 64, when we evaluate that definite integral of our velocity function, and go through, find your, we have our antiderivative that we're using. We're going to evaluate that from 8 to 64, plugging in the 64 minus plugging in the 8. For that value, we get a negative 1,632. And so then our total area, which would be our total distance, is going to be our 96, and then plus we're going to take the opposite of negative 1632, which is a 1632, and we get our total distance is 1,728, and that is in feet. And that is an application of our antiderivative.